Team TevrON welcomes you where we aim in maximizing grid power, minimizing uncertainty. This is our take on creating a renewable energy monitoring system for microgrids. The statement ID 25051 under the Ministry of Odisha. Starting off with our hardware components used in our product TevrON for collecting real-time data, we are using LEM Hall effect current sensor, ZMPT101B voltage sensor, DHT22 temperature and humidity sensor, DS18B20 contact temperature sensor, Apogee SP110 measures solar radiation, Arduino UNO board to process sensor values, LoRa RA02 module for local data transmission, ESP8266 microcontroller for online data transmission, Raspberry Pi 4B for offline data processing, and also using Jetson Nano for prototype testing purpose. Along with this, to cater to a large community of people, TevrON offers 3 deployment modes. The online mode functions by processed sensor data transmission to the cloud and the dashboard via ESP8266 and LoRa modules. The offline mode operates via edge computing, where the Raspberry Pi module processes data and sends alert. This is an example of alert message. Finally, we have an hybrid mode where the flow stays the same. Arduino collects data, pass it to the LoRa nodes, and everything comes into the Raspberry Pi. The Pi runs ML model for anomaly detection, predictive maintenance, and energy optimization. What makes hybrid special is that user get both detailed analysis on the dashboard and instant SMS. Here is a short display of our prototype construction. Firstly, we start by assembling the solar panel as our renewable energy resource for obtaining energy. We are having 3 solar panels for the demonstration purpose. Along with the solar panels, we are adding a wind turbine as well. This way, we will be able to diversify our source of renewable energy. This is the TevrON's monitoring unit. This is the battery bank. We have 2 battery banks for the demonstration. This is a solar charge controller, and we also have used a fan to demonstrate the load. You can see all these components are being connected to each other. This is an overall view of the prototype. Here, the monitoring unit consists of Arduino UNO controller along with the current and voltage sensor. The machine learning model used here are XGBoost, LightGBM, and Advanced Neural Network. We can also use LSTM, long short-term memory. Once sensor data is categorized in the ML model, it is pushed through reinforcement learning model such as DQN, PPO, and A2C to process the anomalies such as abnormal voltage, current readings, and provide an adequate output. This is a sample of how the industrial grade sensor values are taken and processed through the machine learning and reinforcement learning models to provide an adequate data analysis to the user for an output. Here you can see the real-time sensor data are stored in the Firebase. The sensor values are also shown in the monitor. Here you can also see a solar charge controller which optimizes the observed energy generated by the solar panel and the wind turbine. All this data is processed and shown in this way at the TevrON application. This is specifically for solar energy. This is an analysis board. Now, let's take a deep look at the ML dashboard. This is an ML dashboard. The dashboard has an analytic page where the daily power generation, efficiency distribution, weather impacts are present. It has a real-time monitoring page which consists of temperature, power output, etc. And also has a maintenance and report page. Now let's move on to the TevrON application. Depicting efficiency, temperature, and performance inside. This is a segment for the solar panel data analysis. Here is an analysis on the wind power as well from the turbines. The powerhouse shows the battery status. The credit page shows the earned credits by selling the extra power to the main grid. Then use them to buy whenever you need. The TevrON app also offers an regional language support to cater to a wide audience. Along with this, also have an inbuilt chatbot which offer user with assistant to manage their application. Overall, this system is easier for community operator to use and integrate. Thank you for watching.